Hey everyone, my name is Ed, and in this video I'm going to be doing a walkthrough of how to use a Limelight camera on your robot. A Limelight is a combination of a camera and computer, and its only job is to detect April tags on the field. Now this right here is an April tag. These have been specifically designed to be repeatably and reliably detected from an image. The idea is when our camera points at a tag, it should be able to solve for this tag, and in doing so it will know exactly where this is relative to the tag. But we also know where these tags are all around the field. Each tag is unique and we know where it is on the field, so by pointing our camera at it, we can also get where the robot is on the field at any given point in time. This lets us do all these really cool things like accurate path planning, drive to position, automatic alignment to a scoring location, and so on. But to do all of that, we need to actually mount our camera onto the robot. So let me show you that next. So I got my Limelight right here. I'll go ahead and take that out of the box. And this is what it looks like. It can be mounted to your robot through some 1032 screws, and on the back we have some M3 tapped holes that we can also use to mount it. We power this by supplying 12 volts from our robot on the side here. We also have an Ethernet port on the bottom. When we plug this into our robot, we'll be able to access it over our robot's network. Next, I'll show you how I'm going to mount this to my robot. So what I've done is I've made a 3D printed mount for my Limelight. I'll leave a link to the design files for this in the description. And I'm going to mount my Limelight just right there. And I'm going to use some M3 screws from the backside because that's what I have. Okay, now that's nicely mounted. Next, I've already run a power cable, so we need to connect up 12 volts from our robot to the Limelight. So I'll give this a trim, and I'll split these apart. I'm going to target about 3/8 of an inch. Next, I'll wire this up starting with the ground. So I'll push the button, insert the wire, release the button, tug tug, push the top button, insert my 12 volts, release the button, tug tug. Awesome. Next what I'll do is I'll plug in an Ethernet cable. And because this is fresh out of the box, I'm not going to connect it up to my robot just yet. I'm going to connect it up to my computer first to do some initial configuration. Next I'll turn on my robot, and we should hopefully see some lights show up on the Limelight. There we go. And next what I'll do is I'll connect up over Ethernet to my computer, and we'll do the initial setup. The next step is to plug in my Ethernet cable into my laptop, and I'll go ahead and launch the Limelight Hardware Manager. If it asks for permissions, just click yes. And once that launches, we'll go ahead and click Find Devices. This may take a moment, but it pops up there. If you have multiple Limelights connected, it should see them all. If you don't see this or you see some kind of error message, what you should do is go to Control Panel, go to Network and Internet, Network and Sharing Center, click on your Ethernet adapter, go to Properties, click on IPv4, and make sure you have Obtain IP address automatically. Now that the Hardware Manager has found the Limelight, we'll click on the link right there, and it should open up a web browser with the actual Limelight feed. Hello! Now, since this is the first time I'm using my Limelight just out of the box, we need to change a few settings to get up and running. First, I'll go over to the left-hand side and click on Settings, and I'll go ahead and set my team number here. And next, we're going to give it a static IP address, and this is going to match the IP address of our team, and our subnet mask should be 255.255.255.0, and our gateway is going to be our same team address, .1. Now again, this is the IP address for my team. Your team is going to be different. If you have multiple Limelights, you should get each of them a unique name. And I'll click Change IP Settings, and I'll click Change Team Number. It says Power Cycle your Limelight for the changes to take effect. So we'll go ahead and do that right now. Now that our Limelight has an IP address for our robot, I'll go ahead and unplug my original cable. And now I'm going to plug in a new cable. And this time, instead of connecting directly to my computer, we'll go ahead and network this directly to our robot radio. Perfect. And now this time I'll connect up over my robot Wi-Fi, and I should be able to see our Limelight. And now with our Limelight connected up to our robot, and with the IP address set for our robot, I'll go ahead and click on Wi-Fi. I'll connect up to my robot here. And now when I go back to the Limelight Manager, I should be able to click Find Devices, and we now see that camera on the IP address that we gave it. And now the Limelight is all set and networked up to our robot, and we should never really have to change the IP address ever again. And next what we're going to do is adjust our settings to detect the tag as reliably as possible. I can't possibly tell you exactly what settings you need to use, because that's going to depend on your robot, your lighting. So what I'll do is I'll just give you a brief overview of what the settings do, and we'll observe how it changes the tag detection. So you can see the first setting here is exposure, and as I increase exposure, the image gets brighter. However, if we expose for too long, we'll start getting something like motion blur. So in general, we want to keep this low. So I'll leave that at the default value for now. Next, black level offset, you see if I increase this, the image gets darker. And you can use this to start trimming out lights. If you have really bright lights in your room, you can adjust this setting to kind of tone down those lights. The other setting you'll probably need to change is sensor gain. You can see as I change this, the image also gets brighter just with exposure. The brightness comes at the cost of more noise in our image. So I'll leave this on kind of default values for now. And next we'll click on configuration. And the tag family that we use in FRC Robotics is this 36H11. Next we have the marker size. And this is the size of the black box that forms the Able tag. 165.1 is in millimeters. That means the marker is 165.1 millimeters in size. We're going to leave that alone. If you mess with this, that's going to affect all the distances, and you can probably just leave this at default unless the Able tag size changes. Next, we have detector downscale. What this does is it downscales your image by this factor to do the initial solve for the Able tag, and then use the full size the full resolution image to do the refined detection. So you can see if I change this downsampling, you can see I can almost double my frame rate by doubling my downsampling. However, this may not work as well at large distances, so really you just got to play around with what settings work best for your robot. And there's some other settings here like filtering for different tags so you can make sure it doesn't detect certain tags. I won't get into any of that here. Next, we'll click on Advanced, and we're going to want to enable full 3D targeting. And what this is going to do is it's going to draw a box around that tag and do all the 3D math and solving for where the camera is relative to that tag. So now if I pick up this tag, you can see as I move it around, in real time it's solving for where the tag is, its orientation in 3D space. And you can see on the little preview there, where the tag is relative to the robot. So you can view this in a few different ways. You can do your target in robot space. You can do your robot in target space. You can do your robot position on the field. And you can move around using the arrow keys, WASD, kind of like a video game, and get a live preview of where your robot is on the field. To enable this, you will need to upload a field map. This is a JSON file that describes exactly where every tag is and its orientation in 3D space. There's usually a map provided by WPILib for this purpose. Next, what I want to do is tell the Limelight where it is relative to the robot. This is going to be used for getting our robot position. Right now, the camera is telling us where it is relative to the tag, but my Limelight isn't mounted at the center of the robot, and we need to tell it how far off it is. Now, I've used a combination of CAD and measurements to do this. What we're going to do is change the values here. I hover over the information. It says specify the location of your Limelight relative to the center of your robot in meters and degrees. So from my notes, my Limelight is 10 inches forward, which is 0.254 meters, so 0.254. As I change these numbers, the Limelight's going to move around a little bit. Next, I'm 4.5 inches off to the right, which means I'm 0.114 meters to the right, and I'm 7.5 inches up, which is 0.19 meters. I'm also pitched up by 15 degrees. While I'm here, I'll also change my robot size. I have a 20-inch robot, which is 0.508. And the idea here is this visualization should match what I've got here fairly accurately. With that now done, I can go to the drop-down here and click Robot Pose in Field Space. And I'll use the arrow keys here and rotate around so I can see where the robot is. And because my setup here isn't perfect, I don't have a real reef, I've just got the tag on a tripod. I'll go ahead and click Snap to Floor. If my robot saw tag 18, this is where it thinks it is on the field. And that looks, somewhat reasonable. If I then take tag 19 here, I place that in the view, you can see the robot now thinks it's somewhere else because it saw a different tag. So you can see, depending on which tag the robot sees, it will update where it thinks it is on the field.
Now you might be sitting there asking, hey Ed, this is all well and good, but how on earth do I actually use all this? Great question, I'm glad you asked. The first example I want to show you is using the Limelight to update the robot's position on the field. Now, this is going to depend a lot on which Swerve drive you're using, which Swerve library you're using. In my case, I've got a Rev Swerve robot, so I started by downloading the Max Swerve Java template, and I've already got this kind of configured for my robot with the canopies, with the chassis size, with all of that. To actually use the Limelight, what I did is I went to robot.java, and I added in these few lines inside robot periodic. Robot periodic runs every 20 milliseconds as long as the robot's on. And what I'm doing is I'm grabbing the rotational speed of the robot, as well as whatever the current Limelight measurement is. And if the measurement from the Limelight is essentially valid, as in we see a tag and we get an actual solve, and as long as we're not rotating super fast, what I'm going to do is reset my odometry with the Limelight measurement. Now this is modeled more or less after what C-Cherry does in their code. I've simplified it a little bit here. There are other ways, there are better ways to do this, but this will be perfectly fine for demonstration. To do all this, I had to go to robot container, I had to change the drivetrain from private to public, and then inside of the drive subsystem, I added a field map. And inside the drive subsystem periodic function, I update my internal field map with the robot position, and I push that to the smart dashboard. So I'll go ahead and build this code, hide the real log. So what I'll do is I'll launch Elastic here, and what I've got here is the field map showing where the robot thinks it's out on the field, and a camera feed of the actual Limelight. I'll go to my driver station and click Enable here, and what we see is with no tags in view, when I push forward on the stick, the robot drives forward, and the position of the robot actually updates according to the odometry. But as soon as I throw an actual tag in view, so I have 18 here, and if I show that tag, you see the robot immediately jumps to where it thinks it's at on the field. And I can move around, and we see our position updates accordingly. But now, if I show tag 19 here, watch what happens on the screen. See, as soon as it saw a new tag, it jumped, and its position was updated in real time. And this is updating at about 120 frames per second. Okay, the next example I want to show you is what Limelight calls aiming and ranging simultaneously. The idea is once we see the tag, we are going to rotate the robot and drive in and out to get the crosshair of the Limelight lined up with the center of the tag. To do this, I'll go ahead and open up my code, and I've written a command inside a robot container where when we press the left bumper on the controller, which is the bumper right here, as long as that's being held, it's going to run this command. This command will call the robot drivetrain's drive command and let me control in and out with the joystick, left and right with the joystick, but rotation will be computed automatically by taking the Limelight value and multiplying it by minus 0.05. So what this is doing is basically throwing a simple proportional controller on the rotation only of the drivetrain. To get that 0.05, what I did is I pulled up the Limelight feed, enabled the robot, and I rotated the robot until the tag was basically just on the edge of view. And in that position, I see TX is about 30 degrees. That's the value down here. If I rotate the other way, TX is again about 30 degrees. 1 over 30 is 0.03. I did some testing and rounded it up to 0.05, and that's the value we see here. I threw a negative on there to make sure that it always rotated towards the center, and we'll go ahead and test this code. So I'll deploy. I'll go ahead and pull up the driver station and enable my robot. And what you'll see is as I press this left bumper, the robot should rotate towards the center of that tag. So here we go. Just like that. And if I drive the robot forward and rotate it a bit, you'll see it's off center, and I press the button again, and rotates towards the tag. So as long as I have my tag in view, I can press that button and it will automatically rotate towards the tag. We can also do this in the Y direction simultaneously. So what I've done here is instead of giving myself control over the robot in and out, I gave it control from the Limelight. I saw what the range of TY was and found minus 0.1 to work well here. So I'll save that and deploy our code. Okay. Pull up the driver station, pull up the dashboard. I'll click Enable. And this time I'll drive a little bit forward and rotate so the tag's in view. When I press that button, we should see both the robot rotate and drive backwards to get the tag in view. Here we go. And just like that, we can align to a distance from the tag and towards the tag with a single button press. To show this work from another angle, but I still have control over left and right, so I can push to the left of my joystick, and you see the robot tracks the tag in real time. And if I let go, I still have full control over the robot, but as long as that tag's in view, this controller works. But let's say I don't actually want to point at the tag. Let's say there's something just to the right of the tag or just to the left that I want to hit instead. Well, what I'll do is I'll go to Advanced, this point of interest tracking, and we'll shimmy the point we want to track over to the right a bit. So once again, I'll press my alignment button, and now we see the robot is tracking that point of interest, which is off the tag, but it still needs the tag to see it. So I can rotate a little bit, press my button.
I think the last thing I want to show you today is my students built up this little test rig. So we've got a few different Limelights here. We have a 2, a 3, and a 4. And we've got them all mounted up here and networked into one network switch so that I can plug in here and see all of these at once. And what I'll do is I'll open up the web UI side by side and we can do a quick comparison of each one.
Okay, I've got all 3 Limelight feeds open here. On the far left, I have the Limelight 2. In the middle, I have the Limelight 3. And on the right, I have the Limelight 4. And I've got the April tag pushed out to about 13 feet from these cameras. And a few things I'll note is the Limelight 2, we're landing around 20 frames per second. The 3, maybe 40, 45 frames per second. And the Limelight 4 is landing around 90 to 100 frames per second. And most of them are kind of right on the edge of flickering in and out of detection, so I think this is about the limit on the range here. And the 1 and 2 are both running resolutions of 640 by 480, whereas the Limelight 4 is almost double the resolution and almost double the frame rate of the Limelight 3. So that's really cool to see how much better these have gotten over the years. Now, important note, the lighting in my room is absolutely garbage. This is not a good setup for April tag detection, but I'm hoping this gives you a fairly decent relative comparison of these devices. We can also see that the Limelight 2, it has the narrowest field of view, the 3 opens up a little bit, and the 4 is the widest field of view. Now, while I'm personally a fan of how easy Limelights are to use and to get up and running and to work with, they come with some downsides. One of the downsides is, of course, the cost. Limelights are very pricey, and they're very often hard to actually get your hands on. They've been at pre-order only for a while, then they were sold out, and now it looks like they are back in stock. That said, I think their documentation is absolutely phenomenal. I think it's a gold standard for documentation from a vendor for FRC robotics teams. They've got guides on how to set up each of their cameras. They've got setting up the April tag pipeline, what each individual slider is going to do, what you can adjust, and what the trade-offs of each adjustment are. They've got full tutorials here, including example code. These are similar to what I showed earlier. And yeah, if you have any questions, definitely read through this. Their documentation is absolutely incredible. Now, there are a few other vision solutions out now. The Luma P1 is a pretty cool camera. I believe it's about half the cost for a Limelight. And it is also a plug-and-play, give it power, give it Ethernet, you're good to go. And it runs Photon Vision, which is an open source OS for like Raspberry Pi type devices. Another site with absolutely fantastic documentation. It's structured in a very similar way to the Limelight UI, so if you've used one, your knowledge will transfer quite easily. And the cool part about Photon Vision is you can run it on basically whatever hardware you want. A lot of teams run Photon Vision on an Orange Pi, and then they'll plug in a few of these ArduCam modules. And these are cool because you can change out the lenses. They're much smaller than a Limelight or a Luma P1, so you can really mount them wherever you want. And it lets teams build a really customizable vision system. I work for a company that does industrial vision systems, so I have been using a lot of this technology in my day-to-day work. And I think this is some of the coolest stuff that exists inside of FRC Robotics right now, is the vision systems and the automation that the vision systems let us do. So as always, I hope you found this useful. If you have any questions, feel free to drop them in the comments below, and maybe I can help. And if there's any topics you want to see me cover in the future, let me know. Till then, take care.